If you take a look in your book on page 356, the 6.1 notes, that will give you some good examples and a little bit more thorough of an explanation. But for now, we're going to do a quick crash course and just show you how we can solve an inequality by getting x by itself. I've got two inequalities. I'm going to start with this one right here. The x plus 3 is greater than 4. Now I can treat this symbol here the same way that I would an equal sign in terms of how I'm going to solve. So right now there's not going to be any change. X plus 3 is greater than 4. That means that x has to be a number where if I added 3 to it, it would be bigger than 4. If x was 4, then 4 plus 3 is greater than 4, so that would work. But I want to find out the smallest number it can possibly be and still satisfy this. Here's how I do it. I do negative 3 right here. And what I do to one side, I have to do to both. Usually we think of this in an equation. I can do it for an inequality as well. X plus 3 minus 3, these ones cancel, and then 4 minus 3, I'll get 1. That means that x is greater than 1. Same steps that we would take if this was an equal sign, x is greater than 1. If I want to graph this, I'm going to make a number line here. I'm going to go ahead and just call this one 1. And I'll make this 2. I'm going to hide this screen. I'll make this 0, this negative 1, this 3. So it's not exact, but it will work well enough. And on my number line, I'm going to create a circle around the 1, and then x is greater than 1, so I'm going to go in this direction. So even though it looks like the inequality is facing this way, what I'm looking for is more which one is greater. X is greater than 1, so I'm going to go to the right. If x was less than 1, I would go to the left. You can't always use which way this thing is pointing to tell you where the arrow goes. You're going to look for which side the x is on and which way it's facing with x. So just think about if x is greater, go to the right. If x is less, go to the left. Do the same thing over here. If you want to, give this video a pause so you can work through this one the rest of the way on your own. It's a way to check your mental math and your algebra skills. If you want to give that a pause, go ahead. All right, assuming that you've given it a pause and solved it, we're going to go through and do the rest of this one fairly quickly, adding 7 to each side. Negative 7 plus 7, those will cancel. 28 plus 7, I'll get 35. 5x is less than 35 because I just dropped this down the same way I would an equal sign. Divide both sides by 5. So x must be less than 7. I can test this and see if any point less than 7 would still work. I might want it to be something that I can still see reasonably closely will work. So I'm going to just plug in 6. 6 is 1 less than 7. So if x equals 6, I will have 5 times 6 minus 7 has to be less than 28. So let's check that. 5 times 6 is 30. 30 minus 7. 30 minus 7 is 23. 23 is less than 28. Once again, with the number line, I would find a place to start that I think would be reasonable for this number line, and I'm going to actually just put 7 right in the middle. You don't have to start all the way back at 0 or all the way back at some negative number. You're going with the numbers that you think you'll need. So I'll go 7, 8, 9 up this way, and then counting backwards, I'll go 6, 5. And it is greater than, so I'm going to draw an open circle. Sorry, it is less than, so I'm going to draw an open circle and have the arrow going back this way. Now, if it said less than or equal to, that would be my cue to fill this circle in. All right, that's that. The only other trick that we looked at was if there is a negative number next to x, or if there is a negative next to x. In this case, we say it's like negative 1 times x, or just negative x. We're going to do something slightly differently. What I want you to think about is the 5 and 10 comparison. So if I've got 5 is less than 10, right? This makes sense. We can understand that 5 is less than 10. But if we multiply both sides by negative 1, negative 5 to negative 10, even though this looks like a bigger number, this one is higher in value. Think about like the temperature. Negative 10 degrees Celsius is way colder than negative 5 degrees Celsius. So this flips around the other way. Whenever we multiply by a negative, we're going to have to change this direction, right? So right over here, I'm going to do something that I did before. I'm going to subtract 3 from either side, and I will have negative x is greater than 1. But if negative x is greater than 1, and I multiply both sides by negative 1 times negative 1 and then times -1. I'll have to flip this around, and I will get x is less than -1. All right, so it's a quick trick once you've done it a couple times. Let's take a look over here. Same thing. I'm going to add 7 to both sides. I'm still dealing with 35, but I will have to change the direction of this. For now, I'm still at this side because I haven't yet multiplied by a negative number. Now I'm going to divide by a negative number, and we'll see the same result. This will cross out here. 35 divided by -5 is -7, and so this one will also flip around. And we'll go in this direction. X is now greater than -7. All right? That's your quick lesson on 6.1 and 6.2. Here's the homework that is also posted on Canvas.